Hello everyone, and welcome to the KISR International COVID-19 Seminar Series. My name is Bsam Shaheba, and I will be your host and moderator throughout the KICS program, where we aim to present and shed light on the pandemic through a global lens. Today's episode will provide some insights into the interactions between COVID-19 and air quality. I have the honor of introducing our invited expert on this topic, Dr. Rami الفرا. Dr. الفرا is a scientist at the UK National Centre for Atmospheric Science and a research fellow at the School of Earth and Environmental Sciences at the University of Manchester. He has 20 years of experience in the area of atmospheric aerosols and their impact on air quality, climate change, and more recently, on human health. To date, he has contributed to 63 peer-reviewed publications. In addition, Dr. الفرا received the 2008 Atmospheric Chemistry and Physics Award from the Swiss Academy of Sciences. So, without further ado, let's hear what Dr. الفرا has to say.
Thank you very much, Dr. Bsam, and thank you all for joining this seminar. I'll just share my screen to start with. Okay, so in the next 20-25 minutes, I'm going to present some latest research and findings on the interactions between COVID-19 and air quality. The way I'll, sorry, it's not moving, 1 second. Okay. So the way I'm trying to structure this talk is to split it into two halves. The first half, I'll provide a more general introduction to air quality and its relevance and impact, and why it's really important to think about it in this context. And the second half of the talk, I will focus on the interactions between air quality and COVID-19. The picture you see up there in the slide is a simulation from a model that shows the particulate matter, PM, which is one of the key regulated pollutants, global distribution, and the different colors reflect different sources. This is one metric of pollution. The green, more of a natural sources of forests and Saharan dust. The white is the combustion sources, industrial emissions. Pollution is a global problem, and as much as it's important to consider local air quality and impact on people, but also it's important to realize and appreciate that it is a transboundary problem, and once it's emitted, it can be transported hundreds or thousands of miles, and therefore it's a collective responsibility. Over the last few years, we've all noticed a lot more public awareness and attention being given to the issue of air quality. Headlines on various outlets, news outlets, started to highlight the issue of air pollution, how it can reach dangerous levels and affect people, its impact to commuters, cyclists, and different populations, and how it spreads and transported from one region to another. Of course, the issue of air pollution, air quality, was an inevitable consequence and result of urbanization. As more and more people move into cities, we become both the emitters. We contribute to activities, our daily activities emit pollutants, but we are at the same time the receptors. So we are being exposed to pollution in these densely populated agglomerations worldwide. And therefore, air quality is ubiquitous. It's pretty much everywhere, and there's certain level of exposure to pollution wherever we are, whether it's outdoor, indoor, this is inevitable exposure. It's the amount of the exposure, the type of exposure that varies from different location to another. Of course, when we think about our exposure, we should really think about both our indoor and outdoor exposure. There might be different sources, indoor and outdoor. Outdoor with mostly man-made activities, natural and man-made activities, which I will explain a bit more about in a minute. But indoor, we also have a lot of indoor pollution. We have sources from cooking, from various cleaning products, and these are two different things. But our exposure is a continuum of the our time we spend outdoor and indoor. We start all the way back, the Great Smog of London in 1952. This was one of the first sort of big, major, shocking events that brought the whole issue to the forefront of our attention. This was a specific 3 or 4 day period in the winter in 1952, where the conditions were very cold. People were using coal to provide domestic heating, burning coal. This, of course, led to emissions of sulfur dioxide. And under certain meteorological conditions, where you have inversions, the air stays stagnant, doesn't go anywhere, pollution builds up. And you can see here on the right-hand side, this is the mortality rates, the daily mortality rate in London. You can see this period where the smoke went up, the number of excessive deaths also increased. And over 4 days, additional 4,000 deaths were attributed to this episode. This resulted in the first UK Clean Air Act 1956, which restricted inner city coal and wood burning. This is the first legislation in the world to consider air quality and air pollution as an important human health contributor. Of course, in Los Angeles in the United States, the different type of photochemical smoke was also known, but this was mostly from emissions from traffic and car emissions. In the presence of sunlight, intense sunlight, you have photochemical production of ozone and secondary organic aerosols, and that's lead to smoke. This, of course, resulted that California has been leading the way in mandating vehicle emission controls in the 1960s onward to try and restrict the emissions of man-made pollution. Modern day China is our most of a close to mind example of pollution. You can see this image here of Beijing, and you see this probably quite familiar in the Gulf, in the Arabian Gulf, where you have days of haze events or also dust leading to visibility issues and clear pollution episodes. You look at the picture at the top here, it's the same picture taken on different days in Beijing, and you can see how different levels of air pollution manifested themselves in different visibility and effect on the city. This has led to major policies in China over the last 15 years or so, with the electrifying transportation network and industrial emissions. Beginning in 2008 Beijing Olympics, the government there has taken a lot of action to try and minimize air pollution and control it. So you can see that governments worldwide are thinking and worrying about air pollution and thinking about legislation of how to improve it. And the reasons for this is because air quality has lots of impacts on the environment. So this here, I'm not expecting you to follow every arrow and every line. It's just a schematic. The aim of it is to show the impact of air pollution. So these are different pollutants. You get emissions. These are primary pollutants. You could also include secondary ones, which I'll talk about in a minute. And you can see how they impact climate change, impact the environment, the ecosystem from acidification, eutrophication. Then you have the production of ground level ozone, and then particulate matter. These are all important pollutants that have been linked to human health. They've been linked to climate change, and they have detrimental effect on the ecosystem. They also, for example, have effect on crop yields and the biodiversity from different pollutants. So you can see here there's major issues that we have to be aware of and we have to think about in order to minimize the effect of air pollution on us humans as well as climate and the environment.
Okay, is this any better?
So far, yes, I would say definitely. Can we, yeah.
We back online again?
Yeah, great. Go for it.
Okay, I will try now. So this slide illustrates the range of pollutants in a two-dimensional space of time and space. So this shows a wide range of pollutants that have impact on the environment on different time scales and spatial dimension. You can see some pollutants are very reactive, so they don't stay very long in the atmosphere, and therefore their impact will be on a small sort of a geographical space or scale. And then you have on the other end here pollutants that are very inert, therefore they don't react quickly, and they accumulate and stay in the atmosphere, and their effect will be on a global type of scale. And this is similar to examples of this will be greenhouse gases, CO2, And the issue with the climate change is a clear example of this. Just to get my pointer back up again. So this is the very wide range of geographical and spatial impact of air pollutants, and then anything in between as well. In terms of the human cost of air pollution, the WHO has been issuing reports, regular reports and assessments. And one of the most recent ones estimated that 4.2 million deaths every year occur as a result of exposure to ambient outdoor air pollution. Same report quantified the effect of indoor air pollution to be on the order of 3.8 million. This is mostly from countries where they use solid fuel burning for household cooking and exposure. And as a result, the WHO have issued guidance for controlling the concentrations of pollutants in the environment, in the outdoor environment, for things like PM2.5, particulate matter, PM10, ozone, nitrogen dioxide, and sulfur dioxide. And they have limits for an annual limit and a 24 hours or different 8 hours exposure. So these are the guidelines that are recommended by the WHO to try and minimize or mitigate the effect of air pollution on human health. Certain countries have made legislation to enforce these ones at certain different levels, them or different depending on the country. Of course, the alarming statistics is about 91% of the world's population still live in areas where these guidelines are not met. So we have a lot more pollution worldwide than what is recommended by the WHO. The global burden of disease assessments, this shows what is the key factors affecting the global burden of disease worldwide. High blood pressure is the top one, but if we look, we can see ambient air pollution is up there, and indoor air pollution from solid fuel combustion is also very high up on the list. So these two, indoor and outdoor pollutions, are substantial factors in determining the global burden of disease. So what is air pollution? What does it come from, and what are the main sources of air pollution? So we have natural sources, things like sea spray, mineral dust that you are in the Gulf, I guess, very familiar with, and then you have things like volcano eruptions producing a lot of primary natural pollutants. These are pretty much natural things that we have very little control over. Then you have anthropogenic sources, man-made sources, things like traffic sources, transportation, industrial emissions, solvents, all sorts of man-made activities that use combustion sources, fossil fuel, to then emit pollutants. And then we have biomass burning, which could be natural large-scale fires, or could be man-made sort of biomass burning, also emitting a lot of pollutants into the atmosphere. The other distinction I would like to introduce to you is of pollution is primary versus secondary pollution. When we say primary pollutants, these are pollutants that are emitted directly from a source, from a tailpipe of a car, or from a chimney stack in a factory, or from a fire. These are all directly emitted in the form of their chemical form into the atmosphere. The opposite, or the second type of pollution, is secondary pollutants. These are pollutants that are formed within the atmosphere as a result of photochemical production or reactions happening using ingredients from primary pollutants. Once they're in the atmosphere is a big reactor. Chemical reactions take place, and these pollutants like ozone or secondary particulate matter are formed. As far as policymakers are concerned, the primary pollutants are a bit easier to think about, because once you know what the main source of pollution is, you could potentially legislate to reduce the source or mitigate it or do something about it directly at the stack or at the tailpipe. While these ones, you need to understand a lot of chemistry, nonlinear chemistry that lead to their production, and that becomes a lot more challenging for policymakers. This is just a global picture of PM2.5, and you can see here in the middle, the red colors are very high levels of PM2.5. China, India, this is a lot of natural and man-made pollution. The Saharan Desert and the Middle East, you have a lot more of natural background. So although you have very high levels with the same pollutant, the main dominant source could be different between Saharan dust, for example, versus industrial emissions. And this is where it's really important to understand what is the main contribution? What does it come from? What can you do about it as regulatory body or as a policymaker? And here you can see how the different sources of pollution, if it's combustion, you have very high number of pollutants, but very small size. Therefore, their mass is going to be very small. On the other hand, if you have mechanically generated pollutants like Saharan desert dust, there will be a very small number of them, but because they're very large, they dominate the mass. So these are very different sources and pictures, and that has implication on how you control, how much you can do about controlling them. The very final slide of the introduction side is this one is to give you an implication of how pollution is thought about or built up on a regional sort of scale. Every city or country, they will have a natural background of pollution. That's your natural, if there's no one there, this is the level, no activity at all, that's the level of pollution. Then you have your transboundary stuff that get transported from different regions. And then you have your national background. So these are all your background sort of levels. And this will depend on where you are in the world and what sources are around you naturally. And then you have city scale pollution. That's us humans starting to add more activities. And then you have the street level, right, roadside, tailpipes. And you can see these are more acute, more spiky type data. This is more longer term data. And this picture, the proportions of these are different in different places in the world. So you might have very high background levels of dust, and then you have on top of it some of stuff. Other countries will have very little background, and it's mostly man-made. And your ability to control your total pollution, it depends on how much of this is actually man-made and not primary. So I'm gonna now switch gear and talk about the interactions between air quality and COVID-19. And before I go any further, I'm gonna qualify this statement and add suggested interactions. And the reason I say suggested is because it is very early days to be conclusive about any results. There's a lot of talk, there's a lot of discussions and between the on this interaction, but it's very early days for the science process to be complete and rigorous to be able to have firm conclusions yet. We're still in the middle of the pandemic and we're still learning more about it. So there are three main interactions that have been suggested between COVID-19 and air quality. The first one, it's the influence of air quality on the virus viability and transmission. And this is the one I'm not going to talk so much about because it's a lot more of it is from the medical side, it's from the virology and the disease transmission. But there's been some suggestions that conditions of temperature, humidity, indoor versus outdoor environments have influence on the viability of the virus as well as the transmission. One thing I would like to say here, which is becoming more and more established, it seems that there is more and more evidence suggesting that the transmission is a lot more efficient in indoor settings. So indoor settings with poor ventilation. So if you have crowded spaces with poor ventilation, this seems to give more help for the virus to be transmitted and spread. So this is just very important. That has implication on the air quality side, the indoor air quality side, and the requirement for ventilation becomes extremely important. So assessing your risk of getting the virus, this is one of the key factors that people should be thinking about in addition to distancing and hygiene. So I would say it's an equal level, equal importance to distancing and hygiene to think about ventilation of indoor air spaces. The rest of the talk, I will be focusing on the long-term exposure, the association between long-term exposure to air pollution and COVID-19 outcome, and then the effect of actual COVID-19 on air quality. So very early on, we all maybe have seen pictures like this on social media where there are satellite pictures where comparing pollution levels in different parts of the world. China was the first one with the lockdown in Wuhan and general China early on in February and March. We see NO2, carbon dioxide from satellite. This is before, this is January before lockdown, and you see the levels of NO2. The red means very high, and the blue means very low. And you see during the lockdown, these have been completely, almost completely eliminated. This was one of the very early images we've seen, and linking air pollution and COVID-19. And we've seen a similar one from the Po Valley, from Italy, Milan. Again, NO2 before lockdown and during lockdown. And people were getting excited about all sorts of similar plots showing how much reduction in air pollution happened as a result of reduced human activities and the strict stay-home orders and reduced transportation and commuting. And then we started seeing headlines linking or making some early conclusions about airborne particles potentially could be spreading COVID-19 and reducing PM10 PM2.5 levels were reducing the disease spread. I mean, this was very early on. And then other headlines started appearing on linking air pollution to coronavirus sort of outcome. And some studies started suggesting that areas that has historically had very high levels of air pollution, mainly PM10 and nitrogen oxides, have had worse outcomes in terms of mortality and death from COVID-19. So there was The Guardian in the UK published almost five stories on the same topic, and this was very early in kind of March and April. And you see that air pollution is a key contributor to death. This was another one. And there was another study in England trying to link the two together. So these are all headline news that we've seen very early on. In many ways, you could think about it and say, yeah, of course, air pollution is, as I introduced earlier, has a big effect on respiratory and cardiovascular disease, and therefore making the link was quite an obvious thing for many people to do early on. But very quickly, people started taking a little bit of a breath and thinking a bit more about this. And well, other opinions started emerging saying this association is not necessarily is a causation, and it's a very important distinction to make. The fact that COVID-19 was happening in crowded places, in cities, and this is where pollution is generally higher. There is a lot of mixing between the way the disease is spread and the areas. Potentially people who have been exposed to pollution for a long time might be more susceptible to worse outcome, but this is all still kind of like early days really to make solid conclusions. So there is sort of associations, but these simple correlations between air quality and COVID-19 death have often failed to take the other geographical connected factors into the account. So there's lots of confounding factors we need to think about and maybe contribute to both, but doesn't necessarily mean it's causation. People in epidemiology, I think they're very careful about this because personal exposure and general exposure are two different things. And to make a link to individual cases, you have to have more information about personal exposure. And this is where I'm saying it's early days to make these very solid conclusions, but the association has been made. Other people tried to look at the bright side and said, actually, reduced air pollution, it means improved air quality, and this is a good thing. This is something nice to have for the environment, for the ecosystem, for people, for our ability to breathe cleaner air. And this is true. But on the other hand, because this happened during a time when during lockdown, we were mostly indoor environment, we were spending a lot more time indoor. We also should not overlook the fact that we were breathing a different type of air inside. People had a lot more cooking, baking. So we may be producing a lot more pollution indoor where we spent a lot more time. So our exposure has shifted from outdoor to indoor. And this has this has to be quantified in some ways, or it's very much more difficult to do because we don't have systematic monitoring of indoor air quality while we do have this for outdoor. So maybe it's a really good thing to have lower air pollution and improved levels of air quality outdoor, but we need to think about exposure of individuals and how that shifted, and that is an important sort of consideration going forward. But on the other hand, we could maybe think of this as a social experiment where we had sort of insight into the future of reduced fossil fuel and maybe using more electric cars and less combustion engines, and how the world will look in say 10, 20, 15 years time. But is it really this simple?
So 5 minutes, please, Dr. Rami, 5 minutes.
Thank you. So is it really this simple? So what I'll do in the next 5 minutes is just going to show you some actual data from work we've done here in Manchester, trying to understand the effect of the lockdown we had here in the UK and on March 23rd on air quality. So this is data from Manchester super site. We have a super site to look at air quality with a wide range of chemical and physical characterization. And this is the PM2.5 data in black. One key factor I'd like to stress is that when people compare lockdown compared to pre-lockdown, it's not as simple because metrology plays a major role in determining air quality. So where the air comes from, the air mass history, the boundary layer height, the conditions have a major impact on how pollution disperses or accumulates. And here we can see during the period of lockdown, we've done an air mass history trajectory analysis. We've identified 3 clusters where air comes from the west, wet, low, lots of precipitation, and we have low PM2.5 mass. And then during lockdown, the UK actually experienced high pressure and air coming from the south and the east. So European outflow, we had much higher pollution. And this is where the transportation comes. So the contrast was huge between pre-lockdown and post-lockdown, making the comparison between just simple weeks before and weeks after almost meaningless unless you know what the air trajectory and air history is. And we've done this analysis here. So for NOx, we compare the same air history, and we see for NOx, there is the blue ones are the lockdown period, the red data is the pre-lockdown is blue, and red is post-lockdown. And we can see there's a slight reduction in NOx, which is the primary emissions from a reduction in transportation and movement, while for secondary ozone, there's hardly any difference, or in anything, a slight increase in ozone during lockdown. And for PM2.5, it was also similar, sort of not very clear decrease as we saw for the NOx. We've done this analysis across all air quality sites in the UK, but in this case, instead of using pre-lockdown and post-lockdown, we used the lockdown period compared to the same period averaged over the previous 5 years to try and normalize and account for variability in weather conditions. This is nitrogen dioxide. Here is the shift in mean diurnal concentration. 0 means no change. Positive means increase. Negative means decrease. For sites from different urban backgrounds, rural sites, traffic sites, different types of sites. And you can see pretty much across all sites, we have a clear reduction in nitrogen dioxide. The same for nitrogen oxide. So primary emissions from man-made pollution sources have been reduced. These mostly traffic and combustion sources. Ozone, not so much. If anything, it's been actually increased a little bit. And PM2.5, some sites increased slightly, some sites decreased slightly. So the issues there is not as clear. So you can see the picture is not as simple. It depends on the pollutant type and depends on the conditions. So I'll summarize by some few closing remarks. So human exposure to air pollution is significant global environmental burden. We have to be aware of this and think about it for public health measures. To improve air quality, it's important to consider not only the primary sources, but also the secondary formation of pollutions. And that requires a lot more inside knowledge of the chemistry of formation of secondary pollutants. So COVID-19 travel and social restrictions reduced primary pollutants directly from combustion sources and like black carbon and nitrogen oxides. I'm not showing you black carbon, but the same results applied. The effect of these restrictions on secondary pollutants, such as ozone and secondary particulate matter, is a lot less straightforward and depends on the regional sources, transportation, and air mass history. These results imply that reduction in traffic sources, combustion sources, and electrification going forward will have modest effect on PM10, PM2.5, and ozone, and unlikely to help us meet the WHO targets. And we have to think of other policy measures in order to meet these targets. I think I'll stop here. Thank you very much.
Thank you very much, Dr. Rami. Appreciate the presentation. Very informative and eye-opening for sure. Much appreciated. I'd like to ask and invite our participants now to unmute themselves, and would like to see if any of our panel first has any questions they'd like to direct towards Dr. Rami. So please feel free to let me know. Dr. Ashraf?
Can you hear me? Excellent.
Yes.
Right.
Yeah.
يعني if I can يعني say a quick word of appreciation for Dr. Rami for presenting the latest work. Now, I mean, is it fair to say we've expected this? I mean, with reduction in transport activity and some reduction in some industrial activities. I mean, we sort of expected a reduction in primary pollutants, but when it comes to secondary pollutants, then again we've expected it's not going to be as straightforward as with primary pollutants. And also add to this what you've alluded to, and that is the complexity of the situation where you're not changing one parameter at a time. There's so many. I mean, it's a fluid situation. So, if you can maybe in a sentence, Dr. Rami, give us one thing which you didn't expect out of this study.
To be honest, it's from understanding the sources and the processes. I mean, this, as you said, I mean, this wasn't hugely surprising. In many ways, it was almost a confirmatory finding of what we scientifically understood and knew. But it provided policymakers, or potentially it provides policymakers of hard evidence. Almost, I mean, people are starting to publish some of these findings now. So hopefully it will be in peer-reviewed literature. And this will form a sort of strong evidence to think ahead of how we're going to meet our targets of compliance targets with air pollutants, especially on the PM10 and ozone. Because clearly now, if people think the electrification and moving towards electric cars is going to be the panacea for air quality, this is a really clear evidence that they should think again, and we should be a little more careful about how we meet our targets for PM10 or PM2.5. I mean, the other thing which China have already kind of experienced and showed, by going this way and by reducing direct emissions from combustion and electrifying a lot of transportation sort of means, they now are starting to experience a new ozone problem. So ozone levels are becoming much higher in China as a result of reducing primary emissions of nitrogen dioxide. So shifting the pollution emissions from high VOC and high NOx to still high VOC and low NOx is encouraging ozone production and secondary production. And this is something we just have to be careful and think more about how holistically we can do something to reduce these secondary pollutants, because this is going to be the next big challenge for all of us.
I couldn't agree more. Thank you.
Thank you for the question, Dr. Ashraf. Much appreciated. Engineer Fatma or Ms. Shog, would you like to ask any questions?
Yeah, actually everything was clear, and yeah, thank you so much.
Appreciate it. Ms. Shog? Ms. Shog, would you like to add anything? All right, I don't know if she can hear or not. Maybe we'll go on. Is Dr. Muhammad still with us? Yes, Dr. Muhammad Yassin, is there anything you would like to ask Dr. Rami? He's still on mute. I don't know if he can hear.
Can I get permission for another question?
Of course, please do.
Thank you. It would be quite interesting, and again, you alluded to this, Dr. Rami, at the beginning of your presentation. It would be quite interesting to look at the the levels of pollution, air pollution, indoor, while people were actually in lockdown, in complete lockdown, and maybe try to correlate this with incidences of COVID-19. So maybe in an elderly house, one could measure indoor air quality, get a good assessment or characterization of the indoor air quality in this big elderly house, and then at the same time record the number of people diagnosed as COVID-19 positive, and maybe try to see if there is a correlation between the two things.
Well, I would say, I mean, the indoor air quality is definitely something very high up the agenda now of many people in terms of the whole sort of exposure question. In the context of COVID-19, I would divide this into two separate issues, if you like. First, by us spending more time indoor, we are exposed to a lot more indoor emissions. And with the COVID-19, with the hygiene, people have been using a lot of disinfectants to clean surfaces, to clean spaces. People use, various sort of like a bleach. So fundamentally, having a lot of chemicals being used and sprayed around, if the place is not well ventilated, that means you have accumulation of disinfectants and chemicals in the indoor space. And people in there, elderly and young, will be breathing more of these disinfectants and these chemicals. There is potentially also secondary reactions happening indoors, so you have production of secondary pollution. So regardless of the COVID virus transmission itself, the exposure to higher levels of chemical cleaning products potentially has negative effect on human health. And this might probably have increased in the last few months because people are doing a lot of it and spending a lot more time indoor. So that's one issue of the indoor. And this is quite difficult to capture immediately now because we don't have systematic monitoring of indoor air quality. People hardly have this, and unlike the outside one. So it's something going forward. We need to think of how best to capture this and how people can be a lot more aware. If you do cleaning, make sure you open the windows to ventilate. If you smell a lot of this material, then it's not really very good air quality. The second point of the indoor is the transmission of the virus. I can't think of any physical mechanism for having poor air quality indoor that might help transmit the virus. I don't know what this mechanism is, if it exists. I'm not aware of any. But what I know, and I'm becoming a lot more familiar with, is the actual transmission route of the virus, in addition to droplets from sneezing and coughing, which from symptomatic person, it will be obvious, and you hopefully can isolate and kind of avoid the situation, is by just talking and singing and breathing heavily, exercising indoor, we are actually generating a lot of aerosol particles. These are very small particles, unlike droplets, we can't see them, but they are actually all of them can carry virus. And if we breathe enough of them for long enough, this is potentially one of the very effective routes of transmission indoor. And this is what I was saying, ventilation of indoor airspace is probably one of the key measures we need to be thinking about in order to control this pandemic, in addition to distancing and hygiene. So wearing masks, if you end up in an indoors environment, in a public transportation, in a supermarket, in a shop, in a small place where air ventilation is not sufficient, it's really important, very important, to make sure you have mask on and you minimize the time you spend there as much as possible, because it's a matter of exposure, and that transmission route is probably becoming more and more important. And the WHO is coming around to accepting this as one of the key transmission routes of the virus. So indoor is a very important aspect. About indoor air quality overall is a very important aspect in controlling this pandemic. I fully agree.
Thank you.
Thank you once again for your question, Dr. Ashraf. Thanks again for the explanation, Dr. Rami. I have a question, if I may. You touched on the topic of, let's say the issue of this is kind of like a drop in the bucket of meeting the WHO guidelines. It contributes, but not as much as might have originally been thought. And you talked about the need for other things to happen, especially when dealing with secondary pollutants. From your expert opinion, or in your expert opinion, or your perspective, can you maybe elaborate on some of the things those decision makers might consider when trying to reach those guidelines? What kind of actions they could take?
Sure. So I would say there are two main issues here. First, if this question is targeting an area of very high pollution, so if you have an area where you're way over the limit, the target, then thinking immediately of primary pollutants is a very important step. So that's your first step, because that's the stuff you can immediately control by reducing the emissions from combustion sources, industrial or transportation. It becomes a lot more challenging in a much cleaner sort of environment where you are just above the limit or a few micrograms per cubic meter above the limit, where you've done as much as possible, you've done a lot to control the primary emissions. Then the next challenge will be how you get this target kind of like reached. The secondary become a lot more important. In this case, policymakers need to think about the precursors. The precursors that lead to the formation of these secondary pollutants. For example, ozone, ground level ozone production in polluted environments occur because of reactions involving nitrogen dioxide and VOC, volatile organic carbons, and some other chemicals, but this is one of the key ones. So you needed to think about the regime in which you have how much VOC and how much NOx you have, and ozone production changes depending on the ratio of VOC to NOx. So started to think about these kind of elements and trying to see if you can nudge the emissions in a way that kind of favor less production of ozone. And then that could be through NOx control or through VOC control. VOC control, of course, we have industrial processes, petrochemical processes. The indoor environment now, we have a lot of VOCs being used in the indoor environment, and potentially indoor environment could be a source of outdoor pollution. So all these things come into mind, and you start thinking about how you control the precursors that lead to these secondary pollutants. But because it's nonlinear chemistry, it's a lot more complicated, and you have to think of any sort of like unintended consequences there as well.
Thanks a lot. Thank you very much for that.
I mean, I think it was one very brief comment I'll just add. I mean,
please.
Some of these studies that I've highlighted or been quoted in the news outlets by the various media outlets, because of the nature of the conditions and circumstances we were in, very unusual times, some of the peer review process have not been completely followed. So certain research groups have started producing their preprints, which is basically a piece of research they've written up as a manuscript, but this manuscript has not been subject to a peer review, and they've published it online. Some news agencies kind of like jumped on this and looked at the conclusions and made headlines based on them. Of course, because of the nature of the circumstances, people were just hungry for information and they wanted to know as much as possible. So they've used these without the proper peer review process taking place. Some of these studies, I mean, there's a famous one from Harvard, which they've initially estimated that every increase in PM 2.5 mass by even 1 microgram equated to a very high increase in death outcomes of several percent. But they've been subjected to a lot of online criticism for this, and they've revised their studies and tried to confine it more and reduce the estimate. But the key thing there is we have to really rely on properly peer-reviewed literature before we really jump to any conclusions or make any policies or anything like this.
Yes, thank you for highlighting that, because anybody who keeps up with the news now knows that, like you said, there are, let's say, two polarized sides right now, and anytime something comes out, they jump on it and claim it as their own so that they can kind of validate what it is they've been saying this whole time. And that is a very, very slippery slope to go on. especially when you don't have a scientific background and you just see numbers that you think, wait, that makes sense. You know, that reinforces my point of view. And we see this happening in a lot of the countries right now. For example, when the CDC in the States came out recently talking about the 6% number, and people latched onto the 6%, but that just means that, yes, it's only, but it's not just 6% is those who just got COVID outright, doesn't apply to the underlying symptoms, you know, and you go into a whole slew of things at that point. So I could not agree with you more that relying on peer-reviewed sources, especially ones that have done in a very forthcoming and comprehensive way is very, very important. And people should sit back, take a deep breath, and not pounce on anything that they feel is going to reinforce their argument, whichever side it goes.
Absolutely.
Yeah.
I mean, I think it's probably sometimes we feel it's too much to ask of the public to scrutinize and question every sort of piece of information. But in the age we live in now, information is so easy to distribute, and people will do very well if they kind of like scrutinize anything, look for references, look for the sources before they actually spread it around and think about it. And hopefully it's the responsibility of the media outlets to think first about what they publish and what quality of science findings they publish before they actually publish it, because the public are, you know, they can't all the time do this. And it's our responsibility as scientists, as well as the media sort of people, to be a lot more careful about what information they share and how they share it.
I would like to thank you once again for your participation, Dr. Rami, and everybody else who joined us, Dr. Ashraf, Ms. Shog, and Engineer Fatma. Thank you, Dr. Muhammad Yassin, also for joining us. And we look forward to hosting you again in the future on this and any other shows or talks dealing with air quality. You've been very insightful and you provided some really useful information, and I'm sure many people will find it very beneficial to them. So thank you all once again, and we'll see you next time on the Kick series. This is Dr. Bessam.
Thank you very much, Bessam, and all.
Take care.
It was a pleasure. It was a pleasure to meet you all, and it was really good to see you and discuss the issues with you.
Absolutely. Thank you very much. Signing off now, and catch you next time, inshallah. Stay safe, everybody. Thank you. Thank you for watching this installment of the Kick series. And remember, you can keep up to date with our webinars by subscribing below. Looking forward to seeing you all again very soon. Stay tuned. Stay safe.